So a little overview of the presentation. So the main goal was, as told Yannick, modular organization for the modules to be more clear, and also a big thing was the removal of graphical interface dependencies. I arrived on the project in 2001. There were 17 dependencies, so it took like 45 minutes to compile OTB. It was very big. The third thing is going full CMake, because it was a mix of itself, package config, and CMake, so it was kind of a mess for the packaging, for the compilation also. So after going full CMake, we'll see how we revamped the packaging method. We also publish now Docker images, which was not the case in OTB 7 or 8. And we also want to make some deprecations. Okay, un bug. So in 2001, we did here a poll, and we see that there is like 5% or less of all available applications that are really used. So the main goal of this modularization is to simplify the toolbox and simplify also the install process and reduce the installed size, because in OTB 8 it was like 9,000 giga for an install. There was also a need of an easier interface for remote modules like Remedios. And the big goal was also time reduction for compilation, because when maybe people arrive on the project and see 45 minutes of compilation time, sometimes they don't want to take that time. Okay, so on your left, you can see the organization of modules in OTB 8. It was not really clear. We can't see we can't see directly what is in each folder. You can see like the detection and cloud detection is not really clear. So on your right, there is a new organization on OTB 9. We decided to do a lot of reorganization to have 9 folders, and each module that you see on the right is a module that can be compiled separately. So the only thing that you have to compile is the core with the dependencies. So how is organized a module? In OTB 8, there was an application folder which contained the 115 applications, and now we decided to separate application per module. And every submodules have the same architecture with source, include, test, and the same, which is really more clear. So about the HMI components removal, the biggest gain was with Qt, which is a cross-platform library to display GUIs. Just removing this is 150 megaoctet in install size and 15 minutes of compilation time. So just with this, you gain you are going from 45 minutes to 30 minutes. So it's a big gain. With Qt, there was also all graphics related libraries. So we came from 17 to 20 to 12 dependencies to compile, which is a big gain also. And we decided that all the GUI of OTB will be handled by this QGIS plugin. Okay, so about going full CMake, the state in OTB 8 was a mix of make-self, package, config, and CMake, which are all three different, I say, compilation frameworks. And there was also, for packaging, maybe 15 CMake files just to do the packaging, which was a big mess. The advantage of a full CMake approach is CMake is used in a lot of C++ projects. Its syntax is not really easy, but it simplifies a lot if you just use CMake because it's cross-platform and it's very widely used. So there is a lot of information on forums and Stack Overflow. Attends. C'est bon. There was also a big need of CMake code modernization because there was still some CMake version 2 codes. So I took time to do this because now we have a clear code. And the big advantage of CMake is its packaging. It's very, very easy to package, and you can package with, you can do one package, or you can do some modular package. You can package only the core, only the features extraction module, and that's exactly what we wanted. So in the current CMake on OTB 8, there was no clear build target. We could compile OTB targets, but the name was really obscure. And so I decided to make a target per module. So when you want to build maybe 2 modules, you just have to enable OTB build core and OTB build feature extraction, and it will build everything for you. So when you enable a module with CMake, it automatically compiles the dependencies for you. So you can do packaging and a build per module with only activating this command. So it's a big gain of time when you compile it. Okay, bug. So in numbers, we have 50% compilation time gain after all this revamping. It's due to the per target compilation and 12 versus 17 dependencies build. On the packaging process, we gain about 20% because make-self was doing the packaging with calling 15 CMake files, so it was taking a lot of time. And about the continuous integration, we gain in the full pipeline 40%, which is a lot, because every time a developer push some code, the full pipeline goes. And if you gain 40% of time, it's a big gain over years. Okay, so in OTB 8, you could use OTB with a .run file, which was kind of a one-click installer, but it was 200 megabytes for each package, and the installed size more or less 850 megaoctet. Now with the new packaging method, we decided to do a tar GZ, and that's all. So the tar, you just have to one click, or in terminal, you just have to extract it. And the package size came from 200 megabytes to 115, and the installed size goes to 510 megabytes. So it's a lot of gain. But you can also just install modules if you want. So you can install maybe the core and dependencies. And the big advantage is that you can maybe you just install core and dependencies, and you decide that one day you need applications that are in feature extraction. You can just install download the module and install it on top of your installation. So this simplification made a one-click install. There is also an automatic download of Python GDAL bindings, which was a big mess before. So as OTB use its own version of GDAL, you have to get the bindings with the Python version that you plan to use on your system, because if you don't have, you can't do from OS01 per GDAL, and it's a big problem. The Python bindings of OTB recompilation is now working properly, and you can move your installation. About the build system, it's now based on Ubuntu 20, Red Hat 8, Windows 10, and the new thing is that we don't support macOS Intel because it's a deprecated platform. And macOS can be used on only on Docker image now, and the packages are compatible with all these versions. About deprecation, so we deprecate libkml, which is a Google lib that was used in Google Earth, but it's not updated since 2015, so we can't keep it. It's complicated. The macOS platform and is deprecated, and the macOS ARM can't be supported because all the dependencies of OTB don't compile on ARM. So we decided to do the Docker image. And also Ubuntu 1.8, CentOS 7. And like we said in the previous OTB days, we have moved some applications that were not really used in the miscellaneous package, in the miscellaneous module of OTB, because these applications will be deprecated in the next version of OTB. About the Docker image, they are now automatically generated. And we provide the image for Ubuntu 20, 22, 24 with bindings for 3.8, 3.10, 3.12. So I think we cover a lot of use cases with this. And that's all for the evolutions. Do you have questions?